Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about alcohols, phenols, ethers and epoxides. CC6 Unit 2 Lecture 2. So this will be highly useful for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So today we are going to talk about mainly properties and relative reactivity of primary, secondary and tertiary alcohols. So let's talk about properties of alcohols. So alcohols with more or 12 more than 12 carbon atoms are solids. So generally they are odorless. Lower monohydric alcohols are liquids with some smell. Branched chain alcohols like tertiary butyl alcohol is solid. And lower member of alcohols are completely miscible with water due to hydrogen bonding. Alcohols are polar compounds and have intramolecular hydrogen bonding, hence have higher boiling points. Glycols like 1,2-diols have stronger hydrogen bonding than simple alcohols, hence have greater water solubility and higher boiling points. Lower members like methanol and ethanol from solid derivatives form solid derivatives with metallic salts like calcium chloride, CaCl2, 4CH3OH, CaCl2, 4C2H5OH. Hence, alcohols cannot be tried under anhydrous calcium chloride. Then chemical properties. So now we'll talk about the reactions of alcohols. So first is reaction with metal. So alcohol react with sodium, giving rise to sodium ethoxide. So C2H5OH react with sodium, giving rise to sodium ethoxide plus hydrogen. So alcohols are weaker acids than water. So as you can see here, so the alcohol can give rise to proton, giving rise to alkoxide anion plus H plus. So in case of alcohol, we have a R group. So plus I effect. So R releases the electron plus I effect and intensifies negative charge, and the resulting anion is destabilized. Hence the decreasing order of acid strength of alcohol is primary alcohol greater than methanol, greater than primary, greater than secondary and greater than tertiary. So this is the decreasing order. So tertiary alcohol, acid strength of a substance depend upon how well the resulting anion can accommodate the negative charge. Next is reaction with the Grignard reagent. So alcohol can react with Grignard reagent, giving rise to alkane. Then reaction with carboxylic acid. So alcohol can react with carboxylic acid, giving rise to ester. So the reaction slows down due to steric hindrance. So the bulkier the acid or alcohol, the slower the rate of esterification. So the rate of reaction follows this order: methanol greater than ethanol, greater than isopropyl alcohol, greater than tertiary butanol. And next is reaction with acid chloride. So ethanol can react with acid chloride, giving rise to ester. So this is the mechanism. So alcohol, oxygen can act as nucleophile, oxygen lone pair can act as nucleophile. So oxygen lone pair can attack to this carbonyl carbon and CO double bond will break on oxygen. So as a result you end up with this intermediate. So here loss of a proton takes place, giving rise to this intermediate, and when this O minus will come back, it will kick out Cl as Cl minus. So you will end up with ester. Similarly, acid can react with alcohol, giving rise to ester. So carbonyl oxygen lone pair take the proton from acid. So it will be a protonated acid. Then again what will happen? So alcohol oxygen lone pair will attack to this carbocation, giving rise to this intermediate. Again this loss of water molecule giving rise to the ester plus water. The next is oxidation of alcohol. So if we take primary alcohol, it will be oxidized in presence of H plus and sodium dichromate, giving rise to carboxylic acid. So this is the formula of sodium dichromate, Na2Cr2O7, and it is an ionic compound. It simply ionizes to give rise to 2Na plus and Cr2O7 2 minus. And this is the structure of a Cr2O7 2 minus. In presence of acid, you get this compound. So it is unstable and it breaks down in presence of water, giving rise to more stable compound H2CrO4. And H plus can react with water, giving rise to hydronium ion. So while talking about mechanism, so alcohol oxygen lone pair will attack to this chromium center, and this CrOH bond will break on oxygen and it will take the proton from hydronium ion. So you end up with this intermediate. Again here simultaneous bond breaking and bond making will take place, leading to this protonated aldehyde. And again water takes this proton and this OH bond will break on O plus. So you end up with aldehyde. So once you get this aldehyde, it will react with water. So you get 1,1 diol, gem diol. Again oxygen lone pair will attack to this chromium and this CrOH bond will break on oxygen, one OH, and it will attack to the H plus ion. So you end up with this intermediate. So again simultaneous bond breaking and bond making takes place, giving rise to this protonated acid. And water takes this proton and this OH bond will break on this O plus, giving rise to carboxylic acid. So let's talk about reactivity of a primary, secondary and tertiary alcohol. So this is the reactivity order: allyl, benzyl, greater than tertiary, greater than secondary, greater than primary alcohol. This order parallels the order of stability of the corresponding carbocation. And as we expect, the carbocation intermediates are involved in SN1 mechanism. So this is ROH alcohol general formula. So oxygen lone pair will take the proton. So you get this protonated alcohol, and this ROH2 plus will break on O plus. So you get this carbocation, and this R plus plus X minus giving rise to RX. So here generally allyl or benzyl, so these carbocations are resonance stabilized. So that's why that will be more, the reactivity will be more and it is more stable in comparison to tertiary or secondary alcohols. So please subscribe to our channel Chemistry Live UGPG. This is also available in the website www.chemistryliveugpg.com. For class 11th and 12th student, this is the channel Foundation Chemistry AB. So this is a simple step towards e-learning, making life better. Thank you for e-learning.